Hello, welcome to the series on programming with Python and R, and in this video we're going to cover using loops. So what do I mean by loop? Well, to use an even more computer science-y term, this is a kind of flow control. So flow control is a way to control what parts of the code get executed and how many times they get executed. So a loop will take a certain chunk of code and will go through it and execute it repeatedly. So this is a way to avoid copying and pasting code. In the last video we covered functions as a way to avoid copying and pasting your code, so this is another method. And so much like making a function, using a loop makes your code easier to understand and edit because you only have to see that chunk of code once. And so this video I'm going to focus on a type of loop called a for loop, which will go through a series of items and process them one at a time. Now there's another kind of loop that's common in programming called a while loop, which will do the same thing repeatedly until a certain condition is met. But in routine data analysis, you're going to see for loops much more commonly than while loops. So in this video, our objectives are, first I'm going to show you how to construct a loop that goes through a list in Python or a vector in R one at a time. And then I'll also show you loops that will instead use an index. And for cases where you're running a loop and you find that it's going kind of slow, I'm going to show you how to pre-allocate the output so that it runs a bit faster. And lastly, I'm going to show some methods for avoiding loops, or basically making an alternative to loops that's a little faster or easier to read. So that's a list comprehension in Python or the sapply function in R. Okay, so the dataset for this video, you can follow the link in the description to get it off of GitHub. These are a bunch of protein sequences that I downloaded from a website called Phytosome, which is the US Department of Energy, and it hosts a lot of plant genomes. So these are all amino acid sequences for the same gene but across 8 different plant species. So this is the phytochrome A gene, and it's used by plants to detect red and far red light, both for circadian rhythms, as well as they can tell whether they're being shaded by other plants, and that affects whether they try to grow up to the canopy or out sideways to absorb more sun. And so as a reminder, also if you look in the description, there's a table of contents that's clickable, so if you want to jump to a certain part, you can do that. And I'm showing you both Python and R, but I encourage you to be actively following along in just one of these languages. And the other one, just sort of watch it and get a feel for it. You can always go through the video again if you change your mind about which language you want to learn. Okay, so you can see that for this video I set up a new folder, so it'll be a different project, different folder from the previous videos. So I set up a new folder. You can see here I already set it up as an R project. So go back to an earlier video if you don't remember how to do that. And from the GitHub website I downloaded that FASTA folder. And so in there I have these 8 files. Now these are plain text. I opened up one of them in RStudio just to show what they look like as plain text. So if I stretch this out, it's a bunch of lines containing the amino acid sequence, and this asterisk indicates the stop codon. And so the line breaks don't mean anything, they were just inserted for readability, so really this is all one continuous amino acid sequence, and then this is a header indicating the name for that gene. And if I look, I have similar files for each of those plant species. So, to read through those files, I could type in all of the names, but in both Python and R, I'm going to make sort of a shortcut to get a list of all of the files so I don't have to type them out. And so in Python, I'm going to use the OS module, short for operating system. And I'm going to import a function called listdir for listing directory. So let's say FASTA files, FA files equals listdir, and then I'll put in the name of that directory where I have all my files. and then just do a print command to check that it worked. And I will save that again into this new project directory that I made. And so I'll run that to see that it works. Yeah, and so I have the names of those 8 files. And I'm going to be able to make a loop to process those files one at a time. Now, there might be several things that I want to do with them. So say I just want to get this amino acid sequence and I want to put that into a list. So I want to ignore the header here, and then I want to concatenate all of these lines together into one string. And I want to put that into a list. So first I'll set up my list. So let's call it AA-seqs for amino acid sequences. And I'm just going to use these 2 square brackets to initialize it as an empty list before I do the reading. So then I can type this command for FA in FA files. And what this is going to do is it's going to go through this list one at a time, and it's basically going to be like I say, okay, FA equals Arabidopsis phi A dot FA, if I spelled it right, and then it's going to do some stuff, and then it's going to say FA equals cassava phi A dot FA, and then it's going to do the same stuff again. So that's basically what this does, and it's saving me the trouble of having to type these out one at a time, or even index them from FA files one at a time. Like, I don't even have to do it this way, right? This is essentially what's going to happen. Okay, so then underneath that, I will start putting the code that I want to use for processing this. Now the first thing I have to do is make it so it's a full file name with respect to where the script is, so I'm going to have to put that FASTA directory name back in. So let's say full file, just for the full file name, equals FASTA / plus FA, which is going to represent our file names down here. And already I can test this out to make sure that's working like I think. And I'll ignore this line where I printed them out before. Right, so now that prints out the full file name, including the directory for each file. Now that I know that's working, I will put in the command to read the file. So if you remember from our Python file reading before, I'll say with open full file mode equals R for read, and we'll call it my con for connection again. And let's say my lines equals my con read lines. So it will just read all of those lines into a list. Right? And we actually know that we're always going to want this to skip the first line because that's the header line. So even right in here, we can put in 1 colon and then nothing after the colon to say we want to read starting at position 1, which you recall that'll be the second line, all the way to the end. And now how this read lines behaves, it will keep the new line character at the end of each line. So I want to get rid of that too. Oh, actually, I see I've intended by 2 spaces here, but 4 spaces here. Let's make that consistent. Right. Otherwise, I think Python usually gets upset if you have to do it the same way throughout the whole file, basically. All right. Okay, so stripping off that new line character, for now, I'm just going to give you a list comprehension. If you don't understand it, we actually will get back to these at the end of the video. So let's say that my lines equals line.strip for line in my lines. So this is going to pull off that new line character at the end. Right? And then I can say, let's say the amino acid sequence is, and again, this is something that hasn't been totally covered yet, but it's a string method. So I'm going to take a completely empty string and use the join method with it. And so that is going to join those lines together all into one text string. And then I want to add that sequence to the end of my list. So I'm going to use the append function, which we saw before when we were doing reading our data. Sorry, the append method. All right. So now that should be everything that needs to go into the loop. And to check that it works, we can print the whole thing out at the end. So let's try it. Right, and so I do in fact get a list, and I see that it's a bunch of quoted strings, one after the other, and each one does look like, to me, a full amino acid sequence. So let's do the same thing in R, and then we'll have an exercise. So I'm going to start a new R script, and I'll save it in this project directory. All right, so again, I'm going to try to get a list of all of the files in that FASTA folder. So on R, we have a list files function, right? And so that will work a lot like the list dir function in Python. Right, so if I run that, I can see that I can see the beginning of that vector right there. And if I look at the whole thing, yep, there's a vector of 8 file names. And again, I'm going to want to set up an output vector. And again, I'll start it completely empty, right? So we use the lowercase c to construct a vector, and because I'm giving it no arguments, nothing goes into making that vector. Right? Then we have a very similar for loop construction. So I could say for FA in FA files. So that means one at a time, these values are going to get assigned to this FA variable. And a lot like with functions, we use curly braces to group our code. We'll use those here inside our for loop. All right. So slightly less complicated to just read a file. We do need to put in the directory name again though. So let's say full file equals, in this case we'll use a command called paste 0, which will stick these two things together. And again, I can, if I want to just stop right here and say, okay, does this work? Is the loop working? Is my construction of the file name working? I can try it like that. Right, and now I see those printed out. So, great, that part works. We can get rid of this. And so what I would want to do is say my lines equals read lines, full file. And again, if I want to skip the first line, I'll just put a -1 to say ignore the first item in that vector. Right, and then I believe with R, it does not keep the new line character at the end of each line when it does that. So we don't have to worry about stripping that out either. Now to join those all into one sequence, I'm going to use a paste function, which is a lot like paste 0, but anyway. And because it's one vector that I want to glue together all into one string, I'll say collapse equals, and then an empty string to say I don't want anything in between those strings. And then to add that sequence to my list, or to my vector, I'll say AA seeks equals, and then I'll basically construct a vector again. So I'll say, okay, whatever is already in AA seeks is going to be the beginning of this vector. And then after that, I want this new sequence that I created. And I better spell it the same way or it's going to give me problems. All right. You might want to have slightly different variable names for these two things, but oh well. So let's run that. And now we can see what we get in our AA seeks vector. All right, this also looks like what we want. In fact, because it's R, it prints out these numbers, and we can see each item in the vector is a full amino acid sequence that starts with an M and ends with a stop codon. M for methionine. Okay, so what I want you to do now for an exercise, either in Python or in R, is to make it so this loop outputs two lists or two vectors. So have one be the sequences that we just got already, so you'll leave that one as it is, and have the other one be a list or a vector of the headers. So we'll retain the gene names so we can use them later. All right, welcome back. I hope you didn't have too much trouble with that, but if you did, I'm going to take you through the whole thing. So let's set up another empty list we'll call headers. And so we'll want to fill that in too. And in this case, because we don't want to just throw away that header line, I'll get rid of this indexing right here, that slicing that I did to get rid of it. Right, I will still want to strip the new line character off of it. But now just that first item I want to add to my headers list. So I can use the append method again. And I can say my lines 0 because that's where the header will be. So I'll add that to my headers list. Right? And now I want to ignore that first line when I concatenate into my amino acid sequence. So here I'll do that slicing to say ignore the first one. Right, and now let's print out both of those to see if it worked. All right, so I have my amino acid sequences like before, and now I have another list which has all 8 header lines. And if you're doing this in R, the general approach is going to be the same. I'll set up an empty vector for my headers. I'll no longer throw away that first line right away. I will ignore it when I'm making my amino acid sequence. but adding, I will add that first line to the headers vector right here though. All right, and I'm going to start rerunning it from here just so I don't keep adding and adding to this AA-seeks vector. So I'll basically run this line to erase it again. All right, so I still have my amino acid sequences. And then if I run this line, I have my 8 headers. And if you're a biologist, here's one more thing that you can try sort of for a bonus exercise, is go either to the Phytosome website or to NCBI and grab a few more FASTA files containing protein sequences. Preferably one per file, just so that it works the same way. Save those into the FASTA folder and rerun the script. It should work without you having to change anything. You should now see those additional sequences added in and the additional headers. So give that a try. Okay, for the sake of time, I won't demonstrate a solution to that, but hopefully that worked out well for you and kind of demonstrates how you can write your code to be pretty versatile. Like, that's why we didn't manually type out all of the file names. We just sort of retrieved them, and then we have code that will still run if we add more files. Okay, what if we added a lot of files? Like, what if we had, thousands of them? Then you might start realizing, like, this script was pretty speedy before, and it's slowing down a lot, and it's slowing down more than I expected. And that's when we might want to do something called preallocation. So basically what's happening, both the way I wrote this script and the way I wrote the R script, is every time this loop runs, it's adding something to one of these two lists, and the list is getting a little bit bigger each time. And the same with the R script. These two vectors are starting at nothing, and they're getting bigger by just one item each time. And how that works, like on your actual computer, is it's saved aside a certain amount of memory for each of these things. And that is dependent on the size of the list or the size of the vector. And every time you make it bigger, it says, oh, I need more memory. And instead of just taking that place where it already is and making it a little bigger right there, it can't necessarily do that because that next byte of memory might be taken up by something else. So what it has to do is it has to make a whole new one in your computer's memory and then copy the whole thing over. So if you have a list that's 1,000,000 items long and now it needs to be 1,000,001, all of those millions are getting copied. And so that's why that can slow down. So sometimes if we know ahead of time how big these are going to be, we want to initialize them being that big. So what I might do, let's call this n genes. This is the number of genes that I'm working with. Let's say it's the length of the FA files list, right? And we can print that quickly to test that out. Of course, it's going to come before the loop runs, but yep, and so that got 8, right? That's correct. Okay, and so we could use a list comprehension to set these each up as big as they need to be. So by using this range constructor, it's basically making the numbers from 0 up into, in this case, 7. So basically, for all of I in the numbers 0 to 7, it's going to put in a blank character there as a placeholder. And I'll do the same for this one. Now, no matter how many genes I'm looking at, when I set these up, they are going to be set up at the final size that I need. So they're not going to keep getting copied over and over and over again. In my computer's memory, there's already going to be a space set aside for them. Now, that's going to have to change how I construct the loop a little bit, because I'm not going to be able to use this append anymore to keep adding something at the end. I want to add it to a specific position. So I want to know what position I'm in. So I'm going to change the loop construction. And I'm actually going to set it up quite a lot like I did my list comprehensions. Right, so now as this loop runs one at a time, I is going to get assigned to the number 0 through the number 7. In fact, let's make a little test script. To show that working. Right, so that's what I is going to be as it goes through that loop. Okay, right now I no longer have this FA defined, but as I recall, one at a time, FA was going to go through FA files. So to quickly modify my loop, I can say, okay, FA equals FA files subscript I. All right, now I don't need to worry about any of this working correctly now. It should work just fine. Right, and I mentioned that I can't use append anymore because I don't want to make that list bigger. So I can say headers at position I equals my lines 0, which again, that's the first line, so that's the header 1. And then I'll do the same down here. And now I have a script that the output should be exactly the same, it should function in exactly the same way, but now it's a little bit more optimized for if I have a very large data set. So now I can do a very similar optimization in R. So let's say number of genes equals the length of FA files, right? And I can test that out. And genes is 8. Oh gosh, look at me, I've been using equal signs instead of my assignment operator because this is what happens when I go back and forth between Python and R. I won't edit it all right now. You can use either the equal sign or the arrow. It's okay. Right, and so I'll change how I set these two up. And to set up an empty vector in R, it's a little bit simpler. Since this is going to be a character vector, I'll set it up as character, if I can spell it correctly. And then I put in as the single argument to the character function, how big do I want it to be? And I'll do that for both of them. And so, again, I want to now loop through a numeric index for I in. And then I'm going to set up the series of numbers as 1, 2, n genes. So if we look at just what that gives us, we may have seen this before, we get the numbers 1 to 8 by doing it that way. And again, we can just set our first line in here to define what FA is going to be so we don't have to change some of this other stuff. All right, so this line is good, this line is good, this line is good. This one now, we don't want to, or really these two lines, we don't want to keep making these vectors longer now. We just want to insert at the correct position. So we do AA6 seeks I, or headers I, and now we're not going to keep making it longer. We will just slot in our new value right there. So let's clear out our environment and start over, so we can make sure that we aren't using any of our old objects. All right, we have our vector of files. We have the number of files. This L just means it's an integer. Don't worry about the L here. All right, we set up these two empty vectors. We loop through and fill them in. And we should have the exact same results as before. Right, so it works the same, but if I was working with thousands of files, this is going to be much more efficient than the version that I previously had. Now as an exercise here, I'd like you to pre-allocate a vector in R or a list in Python, whichever language you're doing it in, that will contain the size of each protein in terms of how many amino acid residues it has. And for now, it's okay to count the stop codon as one of those. So in R, to get the size of a string, it's the nchar function. So this is how many characters are in that string. Right? Or in Python, you can actually do the length function on one string. All right, so build that into here and pre-allocate like we did before. Okay, welcome back. I hope you had some good luck with that. So let's call this sizes. And I'll pre-allocate filling it in with a number. Instead of a character string, because it's going to be a number. All right. And then I could say sizes I equals len AA seek. All right, so now I have my sequences, I have my header names, and I have my sizes. Okay, if I wanted to do that in R, you may have guessed that if there's a function called character, there's a function called integer, or if you use numeric, that's also okay. And I could say sizes I equals nchar AA seek. So we'll just clear this out and then run it again. And then let's look at the sizes vector. There we are. Now, if I was really teaching you how to do things optimized in R, I would say, oh, well, don't even do this here. Because nchar is vectorized. So I could say do it there. In fact, let me clear this out again and run it again. Oh, I'm doing, sorry, the wrong one. I wanted to do it on the vector, not the last thing to be run. right? So I could do that outside of the loop. And in R, that will make a difference a little bit in terms of computation time. Basically, as a general rule in R, anything that you can do outside of a loop, you should do outside of a loop. But probably this wouldn't be the end of the world if we did it inside the loop. Now, if you're totally satisfied with what you've learned, I give you permission to stop watching. I mean, what I've taught you about loops so far is going to help you a lot. And maybe you already have some ideas for how to use them in your work. But if you watch the last video and you're like, yeah, I really like making my own functions, and Lindsay, you're putting all this code in here, could I put that into a function instead? Let's take a look at how to do that. Right? So let me see. I'll grab my file list from before. And let's make a function called process FASTA. Right? And we'll just give it the file name because that was all that we needed in our loop before. In fact, well, no, I won't change that because that's a pretty good descriptive argument, but we were calling that FA before, so we'll just have to be careful. All right, so let's grab some of this code, paste it in, and then we'll edit what we need to. All right, so we have file name instead of FA. We open that, read the lines, clean them up. And now, since we don't have our lists pre-allocated anywhere here, this is just processing one. Well, that would be kind of silly to say AASeq equals AASeq, so we'll get rid of that. Right, and so here what this does, we've made these three variables, and let's return all three. And especially for me as someone who came from R first, then Python, this is a pretty weird syntax, but it's what it's doing is it's packaging the three of them into something called a tuple, which is kind of like a list, except you're not allowed to edit it anymore after you've made it. So let's see what that gives. We'll call this no loops.py. Okay. And so, all right, it took that one file, it gave us the header, it gave us the sequence, and then it gave us the size. So that's great. You're probably thinking, okay, well, we've been doing a lot of list comprehensions, and I promised to teach you more about list comprehensions. So now that all of this is packaged into a function, we could run it all fairly easily through list comprehension. So let's say process FASTA FA for FA in FA files. Right, so right here, this is quite a lot like how we set up the loop. Except it's collapsed into this nice one-liner now. So again, FA is going to go one at a time through FA files, and one at a time those file names are going to get assigned to this FA variable. And then we're going to process that. So let's see what we get from that. All right. If I scroll up a bit, it's like, okay, here's the one for the last file. with these 3 pieces of information. Here's the second to last file, and so on. But say I wanted to get those back into those 3 lists, like one list for headers, one list for sequences, one list for sizes. You can do that with a function called zip in Python. So I could say headers a seeks sizes equals zip fa output. And that's basically going to take this, what's kind of a list of lists, and sort of transpose it into a list of everything in the first position, a list of everything in the second position, a list of everything in the third position. Oop. Expected 3. And you know what? One thing I forgot is this asterisk, which is going to unpack that list into separate arguments to give to zip, rather than just one argument. All right, now let's try it. Okay, yep, so there's our sizes, there's our sequences, and there's our headers. Now you'll notice they have parentheses instead of square brackets now. That's because they've been turned into tuples rather than lists. But if you needed to convert something to a list, that's all you would need to do. And if you're wondering, is this efficient like the loops we did with the pre-allocation, or is it kind of inefficient like the loops we did where we just made the vector bigger each time, or the list bigger each time? When you do a list comprehension, it pre-allocates the output for you, so you don't need to worry about that aspect. Now let's take a look in R. And likewise, I'll make a new R script. I'll grab this line for how I got my file names, and I'll save it as noloops.r. Okay, so let's say process FASTA is a function, and the one argument to that function is the file name. And I'll spell process FASTA correctly. And let me see. And then I'll grab a bunch of code. All right, and again here, use file name or used FA before. And here we're just getting one thing from that FASTA file. So I won't be putting things into vectors. All right. Now in R, you can't just return 3 things by putting commas between them. And maybe that would be nice, but it's not something it'll let you do. And you might say, oh, well, you could throw them all into a vector, right? But one of these is an integer, and the 2 others are character strings, so they won't go into a vector together. So we can create something in R called a list. And a list is kind of like a vector, except you can put absolutely anything into it. In fact, a list in R behaves a lot like a list in Python. All right. We'll clean this guy out again. And then we'll see if it works on that first file. All right. So here's what we have in our list. The first item in the list is a vector of length 1 containing the header. Second item is a vector of length 1 containing the amino acid sequence. And the third item is a vector of length 1 containing the size. Right, and as we said before, you can't just have like a single value. Well, if you have a single value in R, it still counts as a vector, which is why these are still individual vectors within the list. Okay, so let's say I want to run that across my data set without using a loop. In this case, there are a couple functions called lapply and sapply. And the big difference is that lapply is always going to output a list versus sapply will output a vector or a matrix if it can. If it can't, it will output a list. For simplicity here, let's use lapply. I did a take where I tried using sapply, and the results would have taken a bit more time to explain. So we'll start with lapply, but I'll show you sapply in a minute. So FA output equals lapply. Here, I'll go back to using my arrow here. Alright, so my X that I want to apply across, that's the FA files. So I want to do something to each of those files. And the function that I want to run on each one is process FASTA. Alright, so now if I run that, I have a list. In fact, it is now a list of lists because process FASTA outputs a list. So if I look that, and now it's giving me this like double index. So for there we go. You know, item one within item one is the header, sequence, then the length. Item 2, we get header, sequence, length, and so on. Okay, but again, I would like to put that back so I've got a vector of each. And here's a good chance to use sapply. So now I want to apply something across this list. And I haven't shown you this before, but you can actually define a tiny little function kind of right in place rather than making it ahead of time. And so, okay, the headers are going to be the first item of each of those sublists. So I want to just sapply a function that grabs the first item of each thing. And I can do something very similar for the other two things that I want to get. Whoop. Oh, it's still giving me a list. You know what? Because if you really want just one item out of a list, you have to type the square brackets twice. And I could make this video a lot longer by talking about that. But I mean, this last part is sort of an advanced demo for, like, you know, previewing and thinking about other things you can do. So learn more about lists if you want to learn more about this double indexing. Basically, the double square brackets ensure that you only get one item instead of a list of items. All right. So now I can print out my headers. There they are. I can do my amino acid sequences. There are those. And I've got my sizes. And now I've done all that without using a loop, and I've used these lapply and sapply functions that do some pre-allocation for me, so I don't have to worry about that either. All right, here's one more exercise if you want to practice not doing things in loops. And so right here, we're kind of doing this one at a time, pasting on this FASTA/ to the beginning of our file name. See if you can do that outside of this function, like say like right in here, to make this whole list have FASTA/ at the beginning without using a loop. And in R, you can try the same thing, where instead of doing it in here, you do it up here. So pause for a minute, give that a try. We'll go over the answer, and then we'll be all done. All right. So in Python, we can do that with a list comprehension. And we don't need to define a function here because you can use an expression as well. So right, and then I can get rid of this part. Oh, let's comment it out. Well, no, let's get rid of it because I'm going to have to change then this to file name. All right. So if I run it like that, yeah, that'll work. Let's, we just won't print these parts so it's easier to see. Right, so then this pasted on FASTA/ at the beginning of everything without having to do it within this function that I was then passing to a list comprehension. Again, this whole video is me showing you a bunch of different ways to accomplish the same thing. And always just think of what's easiest to read first, and then secondly, what's going to process the fastest, which in this case, there are probably many very close ties here anyway. All right, in R, so maybe a little bit of a trick because you don't actually have to use sapply. Because many functions in R are vectorized, and paste 0 is one of them. Right. So if I did that, and then looked at what I have for FA files, now they've all got that FASTA/ pasted on the front. And then the rest of this looks like it is still working as it did before, so that's good. So you won't use sapply a lot, not nearly as much as you would use a list comprehension in Python. This only comes up when really you need to use a function that doesn't already have some sort of vectorized versions. And most of the built-in functions in R are already going to be vectorized, in that they'll work on a whole vector at once. Okay, so next time we're going to go over a different kind of flow control, which is if-else statements. See you then.